That's really low. All right, that's fine. Let's look at this together. We're analyzing functions. These are going to be the kind of problems that are like, you know, a train leaves Atlanta at 3 p.m., travels at this speed. A plane follows a parabola path from another city. How or who arrives first? And really, all we're going to be doing is analyzing the different kinds of functions. So what do we know already? We know linear functions. We know exponential functions, and we know parabolas. Okay? So based on the information given, we're going to be creating a graph and seeing which mode of transportation would arrive at your location first. Okay? It's just that the information has been given in different forms, and we have to think about and really rationalize, well, what information can I pull from this? These are just a bunch of points. This is a table. So if I can graph, anytime you have a table, just say thank you, because all you have to do is, that's the x, that's the y, x, y, these are points. You got to plot those out, okay? If you're given 60 miles per hour, again, say thank you here, because it's 60 miles per 1 hour. So how far do you go in 2 hours? 120. How far do you go in 3 hours? 180. And next time you're driving on a long road trip, I want you to look at how fast you're going, or someone's driving. Look how fast they're going. And the amount of miles, I used to do this when I was on the 5, and pretty much I could get it down to like 3 or 4 minutes on when I'd arrive in LA, based on doing this over and over and seeing that. So if you're bored on the 5 driving south, you can always do this. Okay. So working that out in your head. How fast you're going, how far you have to go, how long it's going to take. Okay. So at the end of the class, we're going to look a little bit more, as I fall down, a little more at exponentials, because compound interest, hey, if I borrow $180,000 in 20 years, do I owe $180,000 to the bank? No. So the way banks get rich is they take your money, they put it in the account, they write your percentage rate that you owe above what you borrow, and then you borrow, or you end up owing, you know, out of $180K, probably at my old APR, which I'll talk about more in depth, but I probably would end up paying like $400,000. The house is worth more than $180,000, so I have some what's called equity, some value in it, profit I can take out. I'll elaborate that in a bit, but this is like talking about, okay, this was my mortgage to start, and then I refinanced. I got a new loan at a lower rate to save money in the long run. And you'll see I save a lot of money. Okay, I'm almost rich. I'm almost a quarter millionaire. Yes. Isn't that great? Not a millionaire, just a quarter of it. That was worse. That joke just went. But the arrow was funny somehow. I should just skip the joke and just make fun of the jokes I don't tell. Exactly. All right, so we already know parabolas in standard form have this equation to it. Okay, we know that we can find the axis of symmetry, which may come in handy to you, by plugging in our b value, the coefficient here, over 2 times a, or negative b over 2 times a. And then we know once we have the axis of symmetry, what is on the axis of symmetry every time? The vertex is on the axis of symmetry. If the vertex is here and opens down, it would open in this shape. Remember, the axis of symmetry, which is an x value, can be plugged in to find the y value for it. That's what we've done before. We've done that, find the vertex from this process. So that's something, maybe you look back in your notes, that would be probably around, 212 or 213. Okay, we're then going to have to compare and contrast. So the main thing where we're going to get and understand how we're doing this is going to be the sample problems here. So right now we're just talking about like what elements are included. So when we're comparing or contrasting, you can ask questions like this. Did A or B dive lower? Okay, so I do some scuba diving. There's a special training you have to get to go below 30 meters because it gets much trickier. Actually, 10 meters is as low as you can go until you get the special advanced cert. You can go down to 90 feet. It's much further. So we would be talking about the minimum. So if I just have these two functions, I have the function in black, I have the function in blue. From the graph, if we worked out and had equations for it, we could figure out that which one goes deeper.
Right.
Rhetorical question. No one even wants to answer because it's easy, right? A goes deeper, goes further down. The vertex, if you found the vertex of each, you can compare those, and you would see which one goes deeper. See, these are actually going to be really straightforward questions, what you're asked. Did A or B fly higher? Okay, so maybe talking about different kinds of birds. You would look, again, try to find what the maximum is for each of the functions and compare your maximums. Okay, so minimums is going to be when you're talking about some kind of scenario where you're going down. Okay, or fly higher would be going up. Okay. Which has the greatest y-intercept or initial value? You would just look and see, hey, where does it cross the y-axis? That's our initial value. When time is 0, you're on the y-axis, so that's why we're interested in that part. Okay. So this is kind of like the map where we're going to use. So now let's go and open to that page. Everybody check that page out. You do this with me here so that it is done for classwork. And, whoops. All right, so let's look at this one. Let's look at this one. All right, we're going to graph those 3 different ways to go to the city we're going to. This is time in hours. This is distance. And it's in miles. Okay. So let's do the plane first. The hardest part about these problems is going to be figuring out what does my scale need to be. Because if I make my x and y, I start doing tick marks, and I say, well, my y values are only going to go to 100, then you're just totally messed up because you got 300 to deal with. You got 747 to deal with. Okay. So let's see. The scenario is basically the person has 3 different options to get to their destination. Their destination is how far away? 747 miles, right? You're seeing, based on the information given for each mode of transportation, which would be the fastest way to get there. Who's going to get there faster? So mainly I want to graph it, have the graph down for you, and then you could answer 1 through 3. I'll let you guys answer that small groups. We'll come together with it. So let's first graph, well, we can graph the plane or the car first. They're both going to be pretty straightforward. Which one should we do?
Plane.
Plane. Okay. 0, 0. Find all these points. 0, 0. And tell me, how many hours should I put? Should I put 20 hours or 2 hours? What should my x-axis, how much space should I consider? What do you think? Is there any information up here that might help us? It's not a guess. It's not how you feel about it. It's going to be based on our table. So what is the, how many, yeah. What do you think? 2.5 hours. 2.5. You mind if I do 3? Just to see what's happening after. Maybe some don't line up. I like this. I like this. You got the right idea. 1, 2, 3. Cross country? Yeah. All right, guys. Good luck.
Thank you.
Run hard.
And you guys. Good luck, Emma. Good luck.
Okay. So let's see. Where is it at? Well, first off, where is it at 2.5 hours? It's at the destination at 2.5 hours. So essentially, we're going to compare the other modes, transportation, to the plane. So again, we're looking on page 125. This is numbers 1 through 3 in the workbook for those at home. So at 2.5, that's right here. 2.5. I'm at 747 miles. See you later. Good luck. All right. Where are we at 1 second? You can graph all these points, but I'm going to look at 1 second. And I'm at, where? 300? At 2, I'm at 672. 672 about here. The hardest part is really the scaling. Okay. Now I'm going to put a star right here because this tells us, these 2 points tell us if this is a constant speed or if we're getting faster, or we're getting slower. Tell your neighbor, after you look at it for a sec, these 2 points, at a half hour we're this far, at 1 hour we're this far. Are we getting faster and faster, same speed, or slowing down? So tell your neighbor. Much faster? All right, let's see. Layla, what'd you think? Are we getting faster? Staying the same? Slowing down? Faster. Can anybody elaborate on how we know that? You can do it, yeah. Go on.
So, like, if we were going the same speed each time, we'd be going only 149 faster next time, but that's only, 298. So.
Good. Perfect. If we were going the same speed, after a half hour, we go 149. After a whole hour, twice the time, we should go 298. But that second half hour span, we start to go a little faster. We get a little further than we would go if we were just linear every second. Yeah, Yoli?
Is that table the same table that's on our
I hope so.
Because for 2 it's a 612, not 673.
Okay. And that is going to make a slight difference. It's going to just, I mean, look, I kind of guessed where this is because it's hard to make that much scale. Okay, so thank you for pointing that out. I think that we are going to be good with this just to make our line right there. Now, it isn't completely linear. It is slightly exponential. It does get faster as it goes along with time. So it looks pretty straight, but, I mean, the change in velocity, how fast we're going, wasn't that big of a change. So it's going to essentially be a straight line, but this is the main thing we're interested in. At 2.5, we went 747 miles. We're going to be comparing with that. Can we go that fast, that far? Or can we go that distance, that fast? That's for sure. Let's do the car. The car's next. 60 miles per hour. So after 1 hour, how far have they gone? 60 miles. After 2 hours? 20. After 3 hours? 20. So this isn't totally to scale either. But after 3 hours, we've only got 180. So obviously, that's not faster. That's not faster. Because 2.5, that got us this far for the plane. The plane. The car. Now, if we find, I'm going to let you guys know this. If you find the axis of symmetry from this function, because we were plugged in for the train, we have this function, right? Is negative 2.4x squared plus 90.8x plus 1.59. If we find the axis of symmetry for this, it ends up being at 18.9 seconds. It ends up being way over here, right? So you can imagine the parabola goes way over here, and then it goes back down. So we really aren't going to get much information about this problem from the axis of symmetry. But what amount of time can we plug in to see how far we get? What's the important amount of time that we can plug in? What are we comparing? We already know the plane went the 747 in how many hours? 2.5 hours. So how about this? We look to see if the train gets up to 747 at 2.5 hours. Does that make sense? That's how long the plane took. We want to see if the train gets that far in that amount of time. So we're going to plug in f of 2.5. I want everyone to try this on your calculator because this is not that easy to maneuver around. There's calculators on the front here if you want to grab one. All right, guys, try to work that in your calculator. I got one more up here. Anybody? I got two up here. Who else needs? Anybody else? So you probably have to use a lot of parentheses. You could pull this off doing it all at once, but parenthesize everything. 8 sets of parentheses will be needed. Well, not 8. 7. 7 sets. All right.
Sorry, I'm having trouble with the connect.
Sorry.
I thought it was your calculator. I was like, what kind of calculator do you have? It talks to you? It's like, that's okay. You missed that problem, but you're doing well. Sorry. Does it say just kidding sometimes? It gives you another message. I was saying that was your calculator, so your phone.
Yeah.
Yes, it does. The answer is 300. You're like, just kidding. It's $2.99. Oh, man. Who got that on the calculator once the value assessed? Who got it? Anybody get it so far? Yeah, what'd you get?
213.59.
213? 213? Okay, good. If you didn't get 213, you got to work on your syntax. I think that's what it is. You have a chance in the homework for sure. So let's see. The train gets to 213. It's about here. It gets to 213 after 2.5 hours. So here's the car. So the train, since it's some kind of parabola, I'm going to make it slightly curved, but I want to ask the question first. Where does the train leave from? Does it leave from the same place or slightly closer? Ooh. The answer is in this equation. At time is 0, how far along is the train? Yeah. 1.59 miles. Remember, we learned this before that our C value over here, our C value is our y-intercept. Good, I heard it. So it starts like right there. It starts barely a little bit further, right? I just wanted to do that, so I'm drawing to the same. Whoops. That's close. Okay. So we have our train. All I did was graph each form, and now we got to analyze it. All right, so what is the fastest way to get to the city? What is the, tell your neighbor, tell your partner, talk about it. How do we know which got there faster? Do you know how far each got at 2.5 hours? Remember, this is distance. One sec. This was 213? Yeah, 213. Yes?
Where did you find the equation for the car?
The car, it was just 60 miles per hour. So what essentially it is 60 miles each 1 hour, each hour. So from that, I'm able to graph. Because once I get, here's 60, right, times 1, 60 times 2 would be 120, times 2.5 is 150. From those points, and that information in the points, you could figure out which got there faster. All right, so think about another 10 seconds. Make sure you got it. You guys talked enough, probably. Okay. All right. Wendy, what'd you think?
I'm not sure, but I want to say the plane.
The plane is correct. Anybody elaborate on what? Good. Who can? Yes, other Wendy.
They traveled more miles in just 2.5 hours.
In 2.5 hours, the plane has gone 747 miles. In 2.5 hours, the train's gone 213 miles. The car's gone 150 miles. If it's the same amount of time and one of them goes further, it must be going faster. How far can I walk in 2.5 miles? Maybe 10 miles, maybe. How far can I walk in 2.5 hours? 4 miles an hour? Yeah, I can get about 10 miles in. 4 miles an hour is fast. Without running. Still don't think you guys see that the car is the slowest. See that the car is the slowest? Because it's the same amount of time, but they didn't get as far. The plane is much faster. Why would you even ask if a car is faster than a plane? Unless it's like Southwest. You're going to LA, they send you to Salt Lake City and then down. Does that happen to you? They send you to Arizona and then... that's a good one. All right, you guys ready to see how rich Mr. Pasillas is?
Yes.
Woo!
No.
All right. This is the other kind of problem we're going to have. We have our equation right here. We put our initial as our A value. This is the initial. We're going to put the rate as a decimal. And I already wrote that, didn't I? It's really important that it's a decimal. And this is our time thing. So, the way a mortgage works, before the 1930s, 40s, people had to have all their money saved up to buy a house. There was no mortgage. There was no credit. Credit cards are actually a newer idea in the 20th century. So, you have to buy your house. You have to save up for years and years. Then they have a mortgage. Basically, the bank says, hey, I'll pay for your house, but I'll give you a loan for the amount I give you. You got to put some money down. You got to have some money to put down, like usually 2% or so of your total value. But you basically get a mortgage. You go to the bank or different banks or online services. And you say, well, I want to buy this house. Here's the total value. Here's what I have to put down. So reducing the total cost. What you put down is how much you put in to start. And they'll say, okay, well, you have pretty good credit. So I'll give you a $180,000 loan at 2.25%. 2.25%. So after 20 years, which my mortgage is 20-year, so you can do 30-year, 20-year, 15-year. After 20 years, you're going to pay back more than $180,000. You're going to pay a lot back, a lot more, because it's kind of like money, kind of a loan exchange is. I'll give you an interest rate. You're going to pay the 100 you owe me plus 5%, so you'll pay 105% after 1 year. But that goes up every year, and how much it goes up becomes the amount that you apply each year. Compound interest, which we don't talk about till next year. But if I'm looking at this, what you do is you keep track of what the APR is, the annual percentage rate. And when you see the percentage rate go down pretty far, you might consider, I'm going to refinance my house. I'm going to get a new loan at a lower interest rate to save myself some money, to save on how much in addition I have to pay back. Okay, so this is actually something to really do. Most of you are going to own a home. When you learn about that process, you'll see all these numbers, APR, annual percentage rate. You'll see, the down payment cost, all these things. You want to make sure that you're, in the long run, after 20 years, this could save me tens of thousands of dollars. Okay, it is going to be that big. So what we will do for this is we're going to take our equation. We're going to plug in our initial value, 180,000. And we're going to go 1 plus whatever the rate is as a decimal. And let's see what happens after 20 years. What is this rate as a decimal? It's a percent. I need it as a decimal. So what do? So this one is 0.0425. So this one, 0.03625. My house isn't worth $180,000. My house is worth about $330,000. So I already have equity. If I sold my house tomorrow, I could take out $150,000. That would just be in my pocket. Okay, so this is where you invest your money. Not in a new car, not in like baseball cards or crazy, whatever cards, not baseball cards, 1980s. Not that, that relic. Wait, what were you talking about yesterday? Not the Yu-Gi-Oh card that costs like $80,000, right? You get a house, put your debt in there, consolidate your debt all into your house because you get that lower interest rate, okay? So team up with someone else around you. One person find what the old amount that I'd pay back is going to be. Somebody find what the new amount I'm going to pay back, and then we'll find the difference and see how much I saved. All right, so go ahead and team up, or you can just do both if you just want to do them quick.
Okay. You wanna do that?
You know what? You know what? I have to change something. My old mortgage was over 30 years. So the new mortgage is over 20 years. So you'll find out this one is going to be time of 20 years, this one of 30 years. So actually I think I saved way more than the other classes found out. You guys need to confirm that because I don't want to go, celebrate and spend all that too quick. So this is out. It's not really that. So find how much I'd pay back if it was at this interest rate over 30 years and at this interest rate over 20 years. And then you're really just subtracting to see how much change it was. It's exciting. I think it's more than... So 1 plus 0.0425 raised to the 30th. That'd be for the first one. That's my old mortgage. The new mortgage, that would change to 20. And that would change to our 3.625%.
So what do we do when we have that number now?
So which one did you do? The old one?
One.
The old one?
Yeah.
How much would I pay for that?
627,414.
Okay. Wow. Who else did the old mortgage and saw that I'd pay $627,414? That's a lot, right? The loan was only for $180,000. Why am I paying like 3 times back? Because I didn't have $180,000. They're like, you want your house? You got to pay this back. Yeah.
I thought that like your decimal was lower than one you subtracted.
I see. So this value in here, if it becomes a decimal, it's because it was a decay problem. It was subtraction between them. But the rate can be a really small rate. The rate can be any number. Okay. So because this was 4.25%, we do end up with a decimal here as our rate. But when we add it, we will end up with 1.04. Right. Yeah, it is. Okay, so how much was it for my new 20-year? My 20-year, who got the new mortgage? How much I'm going to pay back?
$366,900.
So look, this action that took me about 5 hours of working, getting documents. Let's see how much. Somebody subtract those and see how much I saved. It's like 200,000 something. 260,000.
Yeah. 501.
So do you think it was worth the 5 hours of work? Somebody divide that by 5 and see how much that was worth to me.
That's at least like 50.
$52,000 an hour. I'll get that. That's somebody makes that much. Somebody's so rich they won't ever be able to spend it. So it's a waste. Might as well burn it. So you see how useful this actually can be. If you didn't understand or know anything about this, you may say, well, we got a pretty good rate. We got a pretty good rate. I mean, look at these rates. Look how close they are. But this one I made over 20 years, so I'm paying a little more each month. You have to pay your mortgage. But look how much I save. Is it worth it? $260,000 is worth it. Okay. Then and 70 cents. Oh man. Those 7 cents. I can almost get taxed on Dollar Tree items. Awesome. Nah, it didn't go over your head. It just wasn't anything. Thumbs up, sideways, down for these different things? Yeah? Okay. Who had never heard of this refi stuff? Anybody never heard of it? First time? Okay. So I hope it's a trick you'll keep in mind when you do have a house. Because over the long run, you're thinking over the long run, this is money that I would never get back. I'm going to get the house with its total equity at the end. You know, after 20 years, it's probably going to be $500,000. But I would have lost this amount. I would have lost essentially half of the final equity amount. Equity is how much it's worth.
Like that
That's how much you have to pay back that loan. So sometimes you have to pay back 3 times the principal, which is how much they have to loans for. Because that interest rate compounds every year. It's compounding every year for a huge amount, over 20 or 30 years.
So then in time, how much you pay back?
Yeah.
Which is divided by whatever the installments.
They would divide this by, let's see, 20 years is 240 months. Divide this by 240 months, and that is about right, about $1,550. That's what it is. Yeah, you save all this money, right?
No, we were like calculating like if we like worked at like minimum wage, like because you're trying to find a base of very minimum amount of time to work to pay off because you're not saved. You have to work at least 987 in a row, straight.
Oh, no breaks, 24-hour days,
Yeah.
indentured servanthood. Yeah. Oh yeah. Throw the trivia all out. Okay, what should we say? Refi your house on 3. Refi. Refi your house. Refi your house on 3. 1, 2, 3.
Refi your house.
None of us have houses but me. I've trained you.